Okay, Oak Rovers, this is a video that's going to help you solve systems of equations when they're word problems. These examples come from Algebra Connections Chapter 6 practice test that I gave. And the first problem follows. Claudia works at a sweet shop making chocolate dipped bananas. Sometimes she drops the chocolate dipped bananas before she can get them to the freezer. Claudia earns 20 cents for each frozen banana she makes and loses 5 cents for each frozen banana she drops. Last Wednesday, Claudia dipped 48 frozen bananas, but not all of them made it to the freezer. She earned a total of $7.60. How many bananas were dropped and how many made it to the freezer? Define your variables and write a system of equations representing the situation. Solve the system by either using graphing, substitution, or elimination. So the first thing I ask you to do is define the variables. And I'm going to let F be frozen bananas and D equal dropped bananas. So those are the two variables that I'm going to have. Now from the first part of this problem, it says she earns 20 cents for each frozen banana. So what I'm going to do is I'm going to take the frozen bananas and multiply them by 20 because that's the money she makes for each banana she freezes. But she loses 5 cents for each banana she drops. So what I'm going to do is I'm going to minus 5 times the number of bananas that she drops. Okay, I'm going to multiply the number of bananas she drops by -5. And when I add that up, that's got to equal $7.60, which is the same as 760 cents. That's one of the equations that I'm going to have. The other equation I'm going to get from the second part. And it says last Wednesday, Claudia dipped 47 frozen bananas, but not all of them made it to the freezer. So I know that the number of dropped and frozen bananas was equal to 48. So the frozen bananas plus the dropped bananas has to equal 48. And those are my two equations on the system of equations. Now, I could graph these, but I think that would be really difficult to make an f-axis and a d-axis and try and graph them. I could solve it by substitution, where I solve my second equation for either d or f and substitute that into in for the other variable on the other equation, in for that variable on the other equation. That's very feasible. But the other thing I can do that I think is even going to be easier than that is I'm going to just use elimination for this one. In order to eliminate one of the variables, I have to multiply my second equation, so when I combine it with the first equation, I lose one of the variables. And it's kind of easy. I have a -5d up here and just a 1d down here. So if I multiply my second equation by 5, I'm going to actually lose one of my variables. So let's try that and see what happens. So if I do that, 5 times f is 5f, plus 5 times d is 5d, and that's going to equal 5 times 48, which is 240. So I've rewritten that equation that I just kind of lightly crossed out into this new equation. Now if I combine my top equation with my bottom equation, I get 20f plus 5f is 25f. -5d and 5d is 0, and that's going to be equal to 1,000 because 240 and 760 is 1,000. I can divide both sides by 25, and I get f is equal to 40. Okay, I'm halfway through this problem. Now I just can use either of my equations, or any of the three equations actually that I have, and solve for d, since I already know f. Well, I know that f plus d is equal to 48, and I know 40 plus d is equal to 48. If I subtract 40 from both sides, I get d is equal to 8. So when I solve the system of equations, I know that I have 40 frozen bananas and 8 bananas that were dropped. Okay, we're going to go on to the next problem. I'm going to try and do 2 on this video, and then I'll do 2 on another video. As the second problem says, the Snow Sports Club from Sierra High School is boarding the tram at Heavenly Valley to ride to the top of the mountain. The tram conductor charges $10 for each club member and $1 for each snowboard. Some members are just enjoying the ride up and don't have snowboards. The conductor collects $179. The number of club members riding the tram is 1 less than twice the number of snowboards. How many club members and how many snowboards ride up on the tram. So again, the first step in all these problems is to define the variables. And I'm going to have B is equal to snowboards. And I'll have M is equal to members of the club. Okay? Those are my two variables. So let's look at the first part of this and get one equation. It says that the tram conductor charges $10 for each club member and $1 for each snowboard. So it's 10 times M plus 1 times board, and he collected $179 from all that. So that's got to equal $179. So that's one of my equations. The second equation comes from the second part, the last part of this actually. The number of club members riding the tram is one less than twice the number of snowboards. Well, when I see the word is in math, that's the same thing as equals. So the club members is, I can write that as M is, or M equals, one less than twice the number of snowboards. So I multiply my snowboards by 2 and I minus 1. So now I have two equations for a system of equations. And this one sets up perfectly for substitution. Because I know that M is the same thing as B minus 1, I'm going to replace that M with B minus 1. And I'm going to solve the problem. So let's write this top equation, or this first equation, but instead of putting M down, I'm going to replace it with B minus 1. So it's going to be 10 times 2B minus 1 plus 1B equals 179. Okay? So now if I use the distributive property, 10 times 2B is 20B. 10 times negative 1, whoops, is negative 10. Plus 1B equals 179. Well, if I combine my like terms on the left side, I get 21B minus 10 equals 179. If I add 10 to both sides, 21B equals 189. I'll divide both sides by 21. And I'm going to get B is equal to 9. Okay? So I know B is equal to 9. Now if I go back to my second equation and plug 9 in for B, 2 times 9, because I know that's what B is, 2 times 9 minus 1 is going to equal to 1, or is equal to M, excuse me. So M is 2 times 9 minus 1. Don't need that parentheses. And then which is 18 minus 1, which is 17. So my club members is equal to 17. And my boards are equal to 9. And that is how I solve that problem. Hopefully, that helped you with the first two problems on this system of equations.